Fabric Flavors have kindly provided a beautiful team uniform with badges for their Badgels collection. Check out their Badgels or their brand new concept store. Click the link in the description below.
Hello, I'm Rian and I'm here with Seb, one of our excellent design and aerodynamics engineers.
Hi, today we'll be talking about an analysis of the CAD tutorial car.
So the first concept that we're going to be talking about today are the wings of this car.
Okay, so first we'll start with the back wings. The back wings, obviously, the shape in itself is not the best of shapes, and there'll be quite a bit of turbulent air at the back, etc., etc. But it is still a good wing, not quite as good as, say, an aerofoil, but I like how it's sort of a cylinder that's been extruded and cut in half. Yeah, I like that, because a sphere is one of the most aerodynamic shapes, if not the most. So this helps to decrease turbulent air and drag generally. The wing plates, once again to decrease turbulent air. I like how they're sort of the same shape as the wing itself, but sort of slightly larger. This helps a lot, and we can definitely use that in our own car, couldn't we, really?
Yes, we could use this feature of the end plates. So the other wings are a lot more complex and probably more aerodynamic, aren't they?
Yeah, so I like the sort of ruptured look of them, and I like how they're sort of sharp at the front and then they curve outwards at the back, and they have sort of little winglets at the ends, which are better, at least I prefer them to wing plates for various reasons. Also, I like how it sort of sorts into categories the different heights, and it just generally decreases drag. Yeah, I really, really like these front wings.
Okay, so the next concept we'll be looking at is the body, which is quite a streamlined, flowing shape, and it's sort of convex, which makes the arc smoother at the back.
Yeah, this also helps to decrease drag and turbulent air, which is essentially what you're doing in aerodynamics. You are decreasing drag and turbulent air and making the car have to push away as little air as possible. But yeah, as you say, Rian, I really, really like the shape. The way that it curves at the front, I like that too. Once again, it helps to sort of sort it into categories. Yeah, and it means that the air doesn't have to travel as far or go as far generally. Yeah, I also like how it curves in slightly and then out. Yeah, I really like this, especially how it's one single shape that sort of changes as it goes rather than two shapes that have been glued together. How is this to make, Rian?
So this was quite a simple shape to make, and it gives off a really good kind of effect for the amount of work put in. And if you want some more detail, watch our CAD tutorials that I voice over. So this body is very easy to make. It's just a couple of sketches and a loft, but the important bit is to make sure that the curve is really smooth at the back, so there's no turbulent air.
Completely. I also really like how the attachment of the back wing is sort of part of the body. That helps to decrease drag and turbulent air as well.
Yes.
Now I believe the next sort of category is side and rear pods. So I really like how the front of the side pods are curved and filleted in many ways, in three ways. The underneath, the front horizontally, and the top. So yeah, I like this. The side pod helps to sort of decrease drag that's going straight onto the rear wheels, and it helps to push air over or under the wheels rather than sort of pushing it onto the front of the wheels. how are these fillets to make, Rian?
So these fillets are really easy, but the important thing about making fillets is actually determining how big you want them, because you don't want them so big that there's no actual pod left and you're cutting to no-goes, which is an important but annoying feature of F1 schools, which you can't actually cut into. So you don't want them too small so that they don't actually have any effect at all. So you can see, if I switch back to a normal view, that the rear pods have slightly larger fillets. So which type of fillet and which size would you rather, Seb?
Well, I would obviously like to have the larger fillets because it's not good to have a sort of a flat surface that the air is bashing into. And I also like how with the rear ones it curves into the back so that there's less turbulent air and less drag, and it isn't a vacuum created there, which you do not want. Yeah, I also think though we are, as you say, limited by the no-go zone, but it is necessary because I think it gives a sort of guide to what shape your car should be.
Yes, another kind of slightly annoying feature is that we have exclusion zones around the wheels. So the front wheel, especially at the back of it, there's a very big exclusion zone, but in F1 cars you want a small exclusion zone so that there's no time for the air to converge around at the back of the wheel before hitting the side pod.
So as I agree with you, and the shape of the rear pod helps to sort of make sure the air that's going on the side of the rear wheel is curved round, as I say. But yeah.
So the next feature we'll be talking about is the nose cone.
Yeah, so this nose cone, it's not the greatest of nose cones, but it does help to sort of supply a similar shape, as we were saying, a streamlined shape for the entirety of the car, so that the air can just follow a single path, which I find is very useful. But then also it has these fillets on the sides, which make sure that there isn't any sharp corners that could make more turbulent drag.
Yes, so a very important feature of this nose cone is that the fillets on the side are the same shape as the fillets, or they're the same size as the fillets on the actual body. This makes sure.
I completely agree.
There's no either the body is bigger, so there's a flat edge which the air can crash into, or the body is smaller fillets, which means the air has to dip into.
So some of the air, as we can see, is pushed sort of under the car, especially by the side pods actually. It's pushed under the car, so that helps to make the air higher pressure, so that then the air speeds up, which will help. The same is applicable to the wings, the front wings, which is very useful. But it can also slow down your car because that means there's more turbulent air.
Yes. So there's also the feature of the Teleline groove, which do you think it's a good feature that there is a massive groove there that lets air through the bottom of the car, or would you rather there not be a groove?
Sorry, I didn't quite catch that there.
So there is the Teleline groove. So would you rather there would be to catch some of the air going underneath, or would you rather there wasn't?
So I'd rather there would be, in some ways, but then in other ways I wouldn't. So the pros for it are that you would prefer to sort of not have a car obscuring the air than to have a car obscuring the air. And also it decreases weight, because if literally just a giant hole through the car. Then also, conversely, it is a source of turbulent air and also a source for drag around that corner, sharp corner, which could be filleted, but this is just a demo car. But yeah, I mean, there is turbulent air at the back, and there's also drag at the front, which is not ideal, but I would prefer to have it overall than not have it.
Yes. So, and the important thing you mentioned was the weight of the car. So just say you can see the mass properties bottom by just clicking this little kind of balance sign, and then it will show you. So if your instance is, you can just fill it in.
Yeah, so then one feature which we have neglected to mention, the wheels. In entry and development class, you can't actually modify the wheels, but in professional class, you can make your own wheels. So what do you think that we would do if we could do that?
So in professional class, I think we would probably make our own wheels, because even though the entry class and development class wheels are very good, they aren't the best.
Well,
and
I mean, they're
multiply.
fairly standard, aren't they? But
They are very standard, yes.
Yeah.
But they do have some features of them which are pretty good. But I think we can make really good wheels which would help speed up our car a lot in professional class.
I also believe that there's actually a tool that we can leave a link to in the description. It's isn't it on the NASA website? Where you can sort of put in the dimensions of a shape, such as a wheel or a cylinder, and then you can actually see the drag. Sort of like a lower scaled.
Very basic sim scale which only has a few different shapes. So we'll link that in the description.
Yeah. So overall, improvements for this car, I'd say if we could, to fillet the front of the Teleline guide, which we can do because it's not actually into the zone due to the fact that we have a nose cone there, which we designed. Then also wheels, if we could, in professional class. The back wings, making them aerofoils rather than the shape that they are. Then yeah, I think that's it.
So, we talked about improvements to this car, but are there any aspects of this car you would think to put in further marks of the official Team Marlin car?
Well, the rear pod, I like that. Also, how the rear wings are the same shape as the sort of wing plate. How the front wings use winglets, I really like those. How the body is one single line if you look at it from the side. Yeah.
Yeah, so thank you for watching, and I hope you have a great day.